Momentum is basically a measure of an object's motion calculated as the product of mass and velocity. The formula for finding momentum is momentum equals m multiplied by v. M for mass and v for velocity. An object with more mass or higher velocity will have greater momentum. For example, a truck moving at 60 has more momentum than a car moving at the same speed because the truck has more mass. Now let's discuss the principle of conservation of momentum. In a closed system where no external forces are acting, the total momentum before an event is equal to the total momentum after the event. For example, imagine two toy cars on a frictionless track. When they collide, the total momentum of the system before the collision equals the total momentum after the collision. If one toy car is initially at rest and the other is moving, after they collide, the moving car transfers some of its momentum to the stationary car. The total momentum of both cars before and after the collision remains the same. This principle is crucial in understanding collisions. There are two types of collisions, elastic and inelastic. In an elastic collision, both momentum and kinetic energy are conserved. Imagine two billiard balls colliding and bouncing off each other. They retain their kinetic energy and momentum. In an inelastic collision, momentum is conserved, but kinetic energy is not. A classic example is a car crash, where the cars may stick together and move as one mass after the collision, losing some kinetic energy as heat and deformation. The change in momentum of an object is directly related to the force applied to it and the time duration over which the force is applied. This is described by the impulse momentum theorem. Here, F represents force, delta t is the time duration, and delta p is the change in momentum. Impulse is the product of force and the time over which it acts, and it causes a change in momentum. For example, when you kick a soccer ball, your foot applies a force over a short time, changing the ball's momentum. This concept is used in various real-world applications, like designing car airbags that increase the time over which they stop passengers, reducing the force and thereby the risk of injury.